also a sort of quasi-living matrix of a whole bunch of living things. So when we're talking about soil as a resource in this class, I'm talking about the sand, silt, clay, the organic material, the dead down organic matter, the O1 and O2 horizons, for those of you who've taken soil science class so far. And necessarily it also has to include all of the biotic components, that fraction of the soil that is wildlife, that is arthropods, in southern Illinois, the brown recluses living out there, and the worms, the other detritivore organisms that are taking that coarse, dead down organic matter, breaking it down into its humic and in some cases fulvic acid counterparts, and kind of digesting stuff like dead wood, dead cellulosic material, dead lignin material, to release that as resources, as nutrients into that matrix of soil. Also moving through that matrix of soil, just like the centipedes, just like the earthworms and so forth, we have gas transport going between one open spot called a pore in the soil to another. All right, so there are measurable rates of gas diffusion as a decaying tree trunk on the forest floor is slowly releasing carbon. You can measure the rate of flow of that carbon dioxide through the soil. A lot of it's going up and out through the atmosphere, but a whole bunch is also going down into the soil. In some cases, that carbon dioxide is turning into carbonic acid when it hits a water molecule in the soil and acidifying that soil, mobilizing those nutrients so plant root hairs can take those up. And in some cases, it's forming other chemical compounds that are carbon rich and sequestering those in the soil. So the soil is this highly dynamic thing. It's just a lot harder to see the dynamism in our soil resources, except when our recreational users, if we're park rangers here, except where our rec users are shredding the soil super hard out of either ignorance or carelessness, like, they're not trying to damage your park, damage our park, but they are just sort of exuberantly experiencing the thing, and the damage is a side effect. Now, for some people, that soil impact is part of the motivation. Okay, so if you've ever seen, raise your hand if you've ever seen like a four-wheel drive truck commercial, or maybe an ATV or UHV, all-terrain vehicle, off-highway vehicle, off-road motorcycle, dirt bike commercial, where it's slow motion and the sun is low in the sky, so it's like dramatic power hour lighting, and you can see like the shocks and the wheels traveling and damping and stuff like that, and there's sometimes these big rooster tails of not soil but dirt. Dirt is soil that's been displaced, getting thrown up out the back, or often you see like the truck swerving in slow motion, or several cars doing like this choreographed thing where they're going like there's a whole bunch of dust, getting spit up out of Bonneville salt flats, something like that. That is all high energy soil transport, erosion, and it is also deposition. So when we're talking about impacts to this resource as a function of recreation, sometimes it's accidental, sometimes it's on purpose. And we have different techniques that we can use in response or in anticipation of those soil impacts as rangers, based on the specifics of the soil resource and the recreation use. Okay, so let's take a couple of examples just real quick. Again, this is all supplementary stuff in addition to the PowerPoints. As you can see, there's a whole bunch of files in here, and it's kind of a lot. So here is some aeolian or wind-based soil transport. This is a dust storm. We all know what dust storms and dust devils are. This is wide-scale landscape soil transport. Now, in this case, it's just a natural process. This part of Utah, so-called Red Rocks country, because this is a sandstone or kaolinitic ultisol, which is a highly weathered with iron impurities present kind of soil. It's that characteristic bright kind of brick red soil. This is fine. This has been happening since a really long time ago, for at least 1,200 years, back to when what is now the desert Southwest was a much more green and verdant and well-watered place, like when Chacoan culture was present and growing corn on top of mesas that are just bare rock now. Okay, so this is not a static system. This is natural, and as park rangers, we don't really care so much about this, except for when we really have to care specifically about this large-scale wind-based transport, because our recreationists have removed whatever tiny bits of soil are present, whatever tiny bits of vegetation, and in particular the vegetation root wads. If those have been trampled or dirt double-tracked, like knobby tires, sort of cutting furrows into the soil, when you remove that grass anchor, that soil is gone with the next windstorm. And that happens a lot, okay? So typically when we see a flash flood in the desert Southwest, which is a pretty common thing, when you get intense rainfall, it doesn't infiltrate like you would expect with a real sandy soil. It flows over land real hard and goes into a dry desert wash, a stream bed, called an arroyo, or a canyon if it's larger. And it's not crystal clear, beautiful water. It is like bright brick red or kind of a real chalky brown color. That's soil transport, and to the extent that your recreationists, or mine, are hiking new trails and exposing that soil surface, that's on us, instead of just being sort of the wind, okay? So, all that to say, this aeolian or wind-based transport is a blessing and a curse. In a dune complex like this one, I believe this one is in like Morocco or Tunisia, so like a classical Saharan desert setting. Or we have a few dune complexes here in the United States, like Great Sand Dunes National Park and Preserve, a beautiful place. Did somebody choose that this semester? Great Sand Dunes? I'm thinking of last year. All right. So when you have people walking on this, there's no vegetation to remove. It's just loose sand. And within minutes, when there is wind present, that wind is going to essentially wipe out the presence, the visual reminder, the releaser cue, like we've talked about, of people walking across that particular kind of soil resource for a recreational purpose, or riding across it on their motorcycle, or riding camels across it, or whatever, okay? So, aeolian transport is good because it rebuilds this continuously. Aeolian transport is bad because it can remove whatever your recreationists are exposing, okay? So when it's a natural process, we rely on it to remove damage. We rely on flash floods and seasonal floods, like in the Colorado River or at Ozark National Scenic Riverways, to periodically scour all of our recreation impacts off of the gravel bars that are heavily used, or the sandbars, or the little islands that are heavily used by floaters, rafters, fishermen, whatever. You get a big, 20, 30-foot flood stage through a real channelized river basin like that, and it just scours everything clean. It's like a planetary level colon blast. It's kind of nice, right? Now, if there's litter and stuff like that, you're flushing that into the waterway. That's not so good. But in terms of just wiping away smaller scale impacts, you can have a pretty heavily impacted place, and a single flood event can completely erase it from the surface of the earth permanently. So, good and bad thing, right? We're not going to demonize, we're not going to lionize the ability of the earth to resculpt itself, but we have to pay very careful attention to where our recreationists are triggering that resculpting. Okay? Cool. If you guys have any questions at any point, again, because this is all supplemental to the slides you may not have had a chance to get through yet, just kind of ask it as we go. Okay? All right, so one thing we can do where we have a very steep slope and potentially where we have soils that are a decent balance, meaning roughly equal proportions, this is a really important detail, roughly equal proportions of sand, silt, and clay. and the presence of lots of very large coarse fragments, not pebbles, but like fieldstone size, boulder size on up, and where we have some organic material, just a few percent, 1 to 2% organic material to mix in. If you cut a trail into a steep slope and you cut that trail down to the underlying mineral soil, that is, we are deliberately removing the O, A, and B horizons if they're present to get down to the mineral soil where there's not a bunch of biological activity. And we compact that down with sand, silt, clay, coarse fragments, and just a few percent of organic material to kind of glue it all together. That trail can last for dozens of years with real close to zero maintenance. So if you're paying attention, that saves you a lot of money. It's a lot of work, it's a lot of sweat equity to cut a trail that is that steep, cut a trail that is gently sloped because it is switchbacking into a very steep landform, a hillside, or even what is approaching a cliffside in steepness. That trail does really, really well because there is very little horizontal, relatively flat space for water to accumulate on that trail surface. It hits the trail and flows right off. Okay? This is a self-bailing canoe, if you want to think of it that way, self-bailing whitewater raft, but for trails. So that means you don't have to cut in a whole bunch of French drains or water bars if you like getting sued constantly, or rolling grade reversals, grade dips, nicks as they're called, and so forth. You just put the trail in on a steep slope and you have the trail running mostly parallel to the contour, not mostly parallel to the hill facing or the slope direction. That is a highly sustainable, this is called a side hill trail, okay? This is a fairly textbook case of that. Now, people hate going up and down switchbacks because it feels like you're not seeing a whole bunch of new space. You're just putting in a whole bunch of sweat equity to get up a slope. So generally speaking, instead of lots and lots of tight zigzags back and forth, you can't see it from the back, we want to have something mostly doing this, running parallel to the watercourse below, but not down in the watercourse, so we're staying out of the mud. And we are staying off of the highly exposed, typically, ridgeline. A lot of people like to hike along a ridgeline. The views are better, the wind is a little bit better to keep the bugs down and so forth. But if you think about it, if the top of a ridgeline is locally pretty flat, there's nowhere to drain water to on the ridgeline, which is counterintuitive, right? We think of ridgelines as these sort of idealized, infinitely thin traces along the top of the hill slope. But really they're not. They got a flat top. And all across that flat top, it's flat. And there's nowhere to get the water. So in a lot of places, the trails that are up on the ridgeline next to trails, maybe in the same trail system, that are down in the creek bed or the valley below, they're both in terrible shape. And then the trails that gently wind up or down to connect the ridge top and the valley bottom trails, they're in great shape. And usually a poor trail design concentrates most of the trail mileage at the bottom or at the top because there are scenic ponds down here, there are scenic vistas up top, and spend way more of their budget than they need to because they're not thinking along the lines of side hill construction. So it was really not till kind of the end of the 90s into the aughts where we were doing research to kind of objectively measure where do you put a trail and what happens to that trail over the next 50 or so years in terms of it getting eroded and blown out and unsafe, full of big cobbles, rocks that kind of collect in trails that become creek beds and stuff like that. You're just collecting bowling ball sized chunks that people like die on, or break legs, or break their horse's legs, and then they die too when the horse falls on them and breaks their neck or cracks their skull. And the research is really pretty clear. Ridgeline trails get beat to hell because they're highly exposed. Valley bottom trails get beat to hell because they're muddy. There's nowhere else for the water to go. It just traps all of that deposited material in these big sucking mud holes. And puddles are all kind of uncomfortable to walk through. But here's the thing. Mud has a suction potential of up to 40,000 pounds per square inch. So if we buried you to the waist in mud and then wrapped like a tow chain around your torso to try and pull you out, or if you were walking in quicksand that got you into some mud and so forth, we're gonna pull your body in half before we pull you out. Does that make sense? So mud is more than just kind of a gross inconvenience. It also, mud puddles harbor all kinds of harmful bacteria for horses. They cannot drink still water out of a puddle like that. They'll get real sick. Yeah, question?
I noticed when I was living in Hawaii, a lot of the like jungle trails were on the side of slopes.
Yes.
But over time, they just kind of became like a bowl on the side of the slope.
Yep.
How do you prevent something like that?
That's called berm formation. Yeah, we're going to go right there and talk about that. Okay, so where you have, that's a great question. Where you have very, very thin soils, basically collected in shallow flat depressions called shields or lenses in like a Red Rocks desert environment like this. You want to keep people off of that soil, all right? So we're in the temperate Midwest, you know, mixed oak, hickory, bottomland hardwoods kind of ecosystem with some mesic, scrubby crap in our forests here. And we can generate soil relatively very quickly compared to some place like this. So when you have, or when you're managing a place like this, or a cinder desert like in many parts of Hawaii, you gotta keep people away from what little soil is there. Those are the spots, those lenses, or those shallow pools of cinder, in the case of volcanic islands like the Hawaiian chain, or you know, Red Rocks country out west here, in Utah, Nevada, places like that, parts of southwestern Colorado. That's all that all of the vegetation and all of the wildlife have to work with. So everywhere else is okay. And you gotta really educate with people, and sometimes literally fence off the few areas where there's vegetation. Because the instinct by a lot of people is to go straight to those only spots where there's any shade. So, vegetation resource dependent on the soil, which in this case is dependent heavily on the parent material, the bedrock. So where the soil is a scant resource, we gotta keep people away. Gotta keep people away from those spots. And you know, there's plenty of other places, like in this animated image, where you can put people elsewhere and not be standing on soil. Plus it's really fun to run around on a whole bunch of exposed, like weathered sandstone like this. Man, it's like, it's zoomies all day long, okay? It's lots and lots of fun to hike around in places like this. So, we will definitely get towards cinder stuff here in a bit. We want to understand that, I need to rotate that video, don't I? The aspect, that is the compass facing, is a hill slope facing north, west, south, or east. Is that aspect causing significant differences in soil moisture? All right, this is something that we see very, very prominently in the Rocky Mountains. This image is not, or this video is not from the Rocky Mountains, but you get the sense of, let's play this one again so you can see it, not cattywampus. Take a look at the different sides of this tree to illustrate the effect of aspect. So southerly facing slopes are going to be hotter, drier, a lot more sun. And those north facing slopes are going to be colder, wetter. You're going to have your ski slopes much later into the spring season in the Rockies, for example. That's why we have brands like the North Face that produce ski gear. And that old saw about moss growing on the north side of trunks, that's not a great way to run your survival program. Okay?
Behind it that has it on the exact opposite side.
That's exactly right. But for the hill slope, this does hold true because it's a much larger thing and it's less susceptible to the individual variations among trees and the canopies and openings in the canopy, the release of resources through down into those trunks that can dry them out in deceptive ways. Okay, so aspect we want to pay some attention to. Let's see. Cinder. Volcanic, here we go. Volcanic cinder soils are very different than what most drylanders or mainlanders are used to. So this is pyroclastically or aeroclastically forged soil particles. That is, where you have hot magma intersecting with the surface of the earth, that is now lava, and in some cases those splattery bits of lava are getting ejected sometimes thousands of feet into the air and cooling and hardening into a shape. Instead of being a liquid blob, they're cooling on the way down, so you get some really weird jagged shapes and lots of volcanic gases, which can be deadly, trapped in bubbles with very thin sort of bubble sheaths or coatings on top of that, so that sheath, when it hits the ground, shatters, and you've got a real sharp kind of circular indentation in that soil particle where that bubble was before it shattered upon hardening. Okay, so cinder soils in recreation context, where you have people hiking, for example, I went through a literally new pair of hiking boots in 5 days doing research at Haleakala National Park's crater area. And half of that crater is covered in lush vegetation. The other half is one of the driest places on the surface of the earth. It is just cinder, and it wore my shoes bald in 5 days of hiking. So about 2.5 days of hiking in the cinder side. Most people are not expecting that. So the soils can also, in a low-key way, kind of attack the recreationist gear and stuff like that. Running powered equipment, especially anything with an internal combustion engine, which is an air-breathing thing and is sucking in some of these like pumice particles and essentially internally sandblasting itself. You can ruin an engine pretty easily by running it through an environment like this. If you've ever heard those kind of apocryphal stories of pilots like in the 1950s and 60s, before eruption monitoring was like a established global automated thing, you'd see planes flying at 10, 20,000 feet before like stratospheric cruise altitudes these days, and they'd get into like the pumice and dust and ash plume up here. So imagine a plane flying through this, and the engine intakes sucking in those things and just destroying the engines pretty quickly, sometimes within a matter of minutes. So the pilots pull up or they pull down and they get out of it and things are fine, so they try to get back to it and the whole plane starts eating itself alive. Pretty nutso stuff. So this is the thing. We want to be aware of what kind of soil is at your park. Is it an ashy, highly, not chemically corrosive, but abrasive soil like a cinder, like a pumice cinder type soil? Or is it something real kind of sticky and soft when wet, like ironically, like a clay soil, which I think this is from Coral Pink Sand Dunes State Park. So each one of these little popcorn balls, this is a bentonite clay hill. Bentonite clay's parent material, volcanic ash. But it's really, really, really old ash, very fine ash as well. And so the finer the particles are, the more electrostatically active they are, the more ion exchanges happening for those of you soil nerds, and so forth. So what happens here is we get a couple of events of rain per year at a spot like this. This whole area gets sticky and completely impassable on foot, by hoof, by tire, by really kind of anything. I mean, it's just a sticky. Imagine walking across wet clay and just getting super bogged down, okay? And then when those clay particles dry, they release that water back into typically the air, or maybe just a tiny bit of recharge to anything below. But usually this is highly impermeable. And all those particles shrink back into popcorn-sized little chunks of super dry, pretty soft clay. So this is another one of those situations where if you walk across this, you're leaving footprints. You are leaving footprints. You cannot be in a bentonite clay hill formation and not feel the soil just crunching down, sometimes multiple inches per footstep, and so forth. But with the next rain, it's going to completely wipe that out. Because that shrink swell is so dramatic, it returns to this sort of brain surface texture, or popcorny texture, almost instantly. Pretty cool stuff. It's also highly, highly erosive. So if you have anything more than a low level of use there, each of those footsteps is eventually going to start to connect with the other footsteps of maybe even a single group of 10, 15 people walking single file, let's say. Like a scouting group, something like that, adventure crew, whatever your jam is. And so you're creating a small new creek bed wherever you walk in an environment like that. And well, that is going to change the drainage pattern and so on and so forth. So with anything more than very, very low or dispersed use, this is something that we need to manage pretty closely. Also with those bright colors, this is a target for people bringing buckets to dig some of this clay and make natural tie-dye like dirt shirts and stuff, like we do for summer camp. Okay. All right, so let's see. Here's a short video of like this video clip. This is America, and I'm not talking about like the Donald Glover, Childish Gambino, This Is America. Like, this is America, right? So let's play this again. Can we just bask in this just for a hot second? You know what? I'm gonna put this one on loop. Okay. Let's loop this beast and play. This messes with my brain because that person looks like they're the size of like a child relative to the size of the ATV. This is specially modified equipment, as you can see. All right, so watch the back wheels. See how the back wheels lock as she brakes to bring the nose back down in the second puddle? Watch very closely. Those treads, 2.5 inches tall, they are gouging through, okay? So, this is a synthetically energetic, that is man-made energy input in the form of, in this case, fossil fuels, that is way, 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 way more intense than some raindrops hitting the ground, okay? Now, raindrops hitting the ground can cause massive sheet erosion in sandy soils. Soils with low adhesion, or stick one particle to another force. Adhesion is stick one particle to another. Okay? Cohesion is stick a larger set of particles to themselves. Okay. So what's going on here is the point of this kind of recreation is to kind of displace some soils and make some noise and pop an amazing wheelie and stuff like that. Yeah, like that's half the fun. Like it gets your pulse up. Has anybody ever done four-wheeling like this? Is it kind of fun? Yeah, it is. Like this is, you know, God did not give us opposable thumbs so we could just like walk across the surface of the earth like filthy plebes. Okay, so, like this is living for a lot of people. The thing is, most soils can't hold up under a single afternoon of this kind of stuff. So, the activity is valid, the motivation is valid, but sometimes the resource just cannot be made resistant to this kind of impact. So, one of our management responses to this might be limiting use, which is, you know, we were talking about at the end of class last time. Our fourth and final and least desirable strategy is to limit use. Say, you can't do this here at this time of year. The soil just will never be able to handle this. But maybe we can move these guys and gals to a sand pit where it doesn't matter how much you do this, because any sand you throw up in a big rooster tail and you water it, maybe that's at the bottom of that sand pit, something like that, it's all just going to flow right back down to where it was and settle in a couple of minutes anyway. No big deal, right? Do that all day long, all night long, all year long. Also on bedrock. Most kinds of bedrock are resistant enough to this. So in places like Moab, Utah, you can rent a Humvee with a pintle-mounted machine gun on it and just drive around and, shoot off hundreds of rounds of ammunition, however much your credit card limit lets you buy for Freedom Seeds, and so on and so forth. And it's not a big deal because it's on bedrock. And yeah, every once in a while we're going to strike a crankcase on that bedrock and chip off a little bit of bedrock and leave some petrochemicals behind, but maybe if you're charging a high enough entrance fee, you can afford that. You can repair or remediate those things. Okay?